that the marine ranching industry in China is doing very well and expanding quickly in only 10 days, 10 years. This growth shows that the marine ranching uh, industry in China is developing very quickly. But as we develop more marine ranching, we also find so many problems or challenges. This problem is the road to make sure our work is sustainable. That is the third and important keyword of our management. Sustainable and efficient. So while we are heading with the progress, we must also focus on the improving. All we do is our major problem is how to observe the change in the underwater environment and the marine life. Right now, we use remote sensing from the satellite and the field measurement. But these two types of data do not work together very well. This makes it hard to use them for daily business operations. As we know, the satellite imaging is often change their update maybe every week or every month. So it will be to the everyday stuff, not quickly enough or enough. This fish industry really needs to commit 3D monitoring system that can check the environment and the health of the exporter. Such a system would help to see what is happening underwater in real time, allowing us to make better decisions. Without it, we might miss important change that affect the fish and the life. This is a big issue that we need to address to progress our ocean resources. And another challenge is that our marine ranching has grown from coast area to the deep and far away things. Imagine this deep sea ranching become a person very hard problem. Currently, much of the information connected during the production is done by hand. We also use our eye, our nose to know the changes of the water quality. Look at the good ways to combine data from the different sensors. Also, we do not have a reliable forecast for things like the water temperature, salt level, water flow, and GO in the near sea area. We do not fully understand the biological resources and feeding the fish. It's often based along the past experience. This leads to overfeeding, which food and can harm the environment. We need to build a smart and systematic control system that can automatic this process and make them more efficient. This is also another important problem for who will do the work in marine ranching maybe in the future. Even though China has a lot of population, right now is about 1.4 billion. But fewer people are willing to do this hard work in this field. It is very hard to find young people in the farm, agriculture farm. So maybe such like the age of I, that's more than 40 years old. They are just very hard to find fewer people in the younger age. So maybe in the future, there's fewer and fewer people will join our job. So the farming cucumber still depends on divers, which is risky and costly. So most operation in marine ranching only rely on the manual labor, leading to high cost and 50 with too slow we need to research develop high process equipment that require fewer people to operate. This would make the work safer and more efficient, attracting more young people in the future can find our job. As we know, the traditional marine ranching method seems unable to fix the three big problems that I just mentioned before. So we try to find a new way to solve the problem. We turn into the new technology, just like Beidou and remote sensing. You maybe everyone already know what about the remote sensing, since sensing. But Beidou might be a new to everyone. Beidou is a Chinese word that means to speak deeper in English. Both of them have the same abbreviation, BD. Long ago, this Chinese people used to speak deeper, as we say Beidou, to find directions. Today, we use Beidou satellite to system for visitation. In simple terms, Beidou is like Chinese version of GPS, but it's more accurate. In the Asian area, it can pinpoint the location within centimeters, and globally, it is accurate about 2.5 to 5 meters. And this is high precision. It's very helpful for our work. With the help of Beidou and remote thinking, we have a good chance to solve this bottleneck problem. We can get very exactly location information, and with high quality road scene image, we can build better models to understand the ocean. This leads to more accurate results and allows for fewer control of equipment. For instance, we can get unmanned boats more processes or monitor water condition in detail. This technology open up new possibilities for making marine ranching smarter and efficiently. Allow me to give an overview of our project. This project started in December 2021. This year it will be finished. The idea is to combine Beidou precision and the high resolution remote sensing for marine ranching. Our goal is to create an intelligent information system and an unarmed manned underwater operation framework within the space marine information industry. This means we want to use space and the ocean data to manage research without needing many people on site. It's a big step towards modernized marine ranching. Our research had to 4 parts. First, we plan to set up a monitor network to connect the data from the ocean. And then using this data, we will develop a measurement and control system. Next, this system will send commands and orders to unmanned operation equipment. And finally, we aim to apply all this in a new marine launch demonstrate area to show what it works. This step connects and will help us to build a complex situation solution for some smart marine launching. To achieve this, we have been working on three area for research. The first is to set up observation nodes, which include boys that stay in one place and unmanned vessels that are moving around. This, this new technique from a network, uh, and by using voice at different steps, we can combine data from its level water, remoting in space. This creates a 3D operation network that can give us a full view of the ocean environment. With the data from the network, we can evaluate the structure, and the recent copy of the food research in marine ranching. Based on this evolution, we use intelligence control system to make decisions for the entire product cycle. Then the system then operation industry introduction to unmanned equipment, which carry out tasks like feeding or monitoring. Lastly, we need to test everything in a real location to provide to free. It is real effect. The next, okay. Next, I will talk about the group we have made so far. We have the process and reliable data speed time return for Earth at sea by optimizing setting, improving perform, and making it easier for user. We have created a high process navigation method for unarmed boat based on the graph of this mission. We also studied water sounds and visual slam motion station knowledge. This instrument has been installed on unmanned boats and on the water away, and we have tested in the demonstration area. The test shows accuracy of about 1.17 meters, which is very good for us. Next. Based on the optical satellite, remote seeing image, and real-time data from Boeing, we have set up productivity remote seeing method for checking water quality in marine. This allows us to monitor things like temperature and salt levels from space and combine them with on-site measurement. The next. We have accumulated the route remote seeing quality reverse and both remoting by automatic parameters using satellite data. We can observe the seafloor temperature, salinity, and wind field in the water around the Shandong Peninsula with high processing. This gives us a conditional large-scale data that is essential for marine submarine launching. We have built a sea, land, integrated ocean and air operation network for marine launching. This network connects data from the land, sea, and the air to give us a complete picture. It helps us monitor the water and the ocean conditions together, which is important for prediction, the change, and preventing the disaster. We have also done a process in study of agriculture quality in marine ranching. By use deep learning algorithm, we can accurately find and map for facilities like stages and routes with accuracy of at least more than 19%. to help us know where everything is and how it is doing. Oh yeah, it's on the detail extraction of marine ranching quality. We can get information on the type, structure, and the spatial distribution of targets such as kids, rafts, and ponds in each area, which have developed yield information meld using remote sensing related to unit seaweed yield. This model helps us to predict how much seaweed can we harvest, and it has a accuracy of 17.5. Additionally, we built a fish intake prediction model for next hit from fishing using nuclear network algorithm. This system can reduce fish care cost by 20% without effect fishing growth, making feed more efficient and less wasteful. We are researching process control and continuation method for momentum marine ranching equipment. This allows multiply unmanned boats to work together in network, improving efficiency. We have introduced a precision farming system for the pair production cycle with modern updates every 30 minutes. This means the system can adapt quickly. We are also developing the coordination control method for surface unmanned boats and underwater robots. This force share position information and can assign tasks and observation tests in real time. We have achieved a path tracking accuracy of better than 3 meters, which is very reliable for. We have developed various types of unarmored operation equipment that cover the whole production process of marine ranching. This is including the boats for monitor, feeding, and inception, as well as reports for the harvesting. System machines can help automatic tasks that use to require a lot of manual labor human beings. Reduce the cost and the risk, and they are designed to work in different conditions and can be more controlled remotely, making marine ranching more modern and efficient. Now, let me move into the final part, summary and the process facts. Our main achievement is the establishment of the intelligent processing, intelligent control, and intelligent operate technology system. We have developed a Beidou sport monitor buoying and unmanned boat and on our way. This allows us to create a 3D view of the whole marine ranching environment and the underwater condition. We use 4D real-time simulation and 3D reconstruction to improve the model and make better. Yeah, we have established all cycle measurement plant farm for marine ranching. This process helps build information-based and intelligent product system for breeding and real interaction. It forms a new integrated developed model called Marine Ranching Plus, which combines different activities to make the whole system more simple. Uh, we are advanced to underwater high process navigation and position, and we are working on process control under current interference. This enable auto inspection and collision avoiding for the our ways. We have developed unarmed vessel for tasks like fight feeding, net cage inspection, political research monitor, and harvesting. This is the Intel Marine Ranching production program from start. Mhm. We, I will introduce a video for us, for all of us to see what we do. Looking for the future, the development of modern marine ranching will focus on the storing the seagrass bed, oyster reefs, and the coral reefs, and build ecological reefs. On one hand, we will create freshwater ecological ranking and control water quality from the source. In intertidal area, we will restore mongoose, tamaki, and other salt talented plants to build interdictal electrical ranking that help with reef stabilization and pollution reduction. The shore, we will restore the seagrass bed and seaweed fields and place some artificial reefs and oyster reefs to support the reef fishing and diving tourism. In deep sea area, we will develop large-scale agriculture improvement, such like the night stage, gravity-based agriculture workflow. We will integrate with the offshore wind and the wave energy to expand ranching area. Modern equipment such as unmanned boats, joys, harvest robots, and monitor platform will provide intelligent process, control, and operation across the marine ranching area. Finally, I would like to express my sincere gratitude for the strong support for the National Key Research and Development Program of China, the National Natural Science Foundation of China project. The companies involved, your help has been crucial to our process. That's all of my presentation. Thank you for your attention. Thank you very much again.
Thank you. Thank you very much, Professor Cheng Gang-Lin, for addressing the interesting topic. Now, we have a discussion session. Dear all participants, if you have any questions, please raise your hand. Please.
Thank you. First, thank you, Professor Cheng Gang-Lin, for your nice and presentation. I have a question. What are the challenges in the ranching in China after applied unmanned technology? Thank you. Yes, what are the challenges in China ranching after applying unmanned technology?
Thank you for your question. I want to try to answer it. In my opinion, the challenge is the situation between the marine ranching area is far away from the land. So the distance is very long. We can have the good communication ways. So and have a lot of energy. Without the energy and just like the Wi-Fi, we can't count the information friendly. So maybe it's the big challenge, or maybe the most challenge we have faced. So we have to try to build some wind, wind offshore wind farming to produce the energy and to give us some line to translate the information to solve this problem. But this is only the near sea. But if we go from the shell, maybe 20 kilometers away from, it's very hard. Such large so this is the major problem. We will find some lab information as the presentation to some leaf product engine approach to use some engine for the launching instrument to the emergency conduct. I don't know whether my answer is good. I'll try back.
Yeah, any questions here? So we move to Q&A box. We have some questions. Let me to read the Q&A box. The first question from Nurfianto Giar Pangidung. He asked about how can we build a seamlessly integrated intelligent ecosystem of autonomous systems powered by real-time data. Yeah.
I want to answer it. It's a very complex question. So many things. How can we implement? We just like response to the real-time data from the voice and the things, the they like things to collect just like the environment data and the cucumber and the fishing data first, and to use the model which is suitable for this area model to communicate the marketing product new and user process. So that's it. We use EcoPath model to communicate the marketing product team. But this model needs to change in another area. So we need to know the situation in our production area to know this program to choose the appropriate way. So we need to get the the right and the real time data. The first thing. The second thing is to find a suitable model to calculate the marketing. And the third thing is to try find the model we have to choose is right or not. If it's not suitable, we will change the model to the good. The focus. Oh wow. In the sense of we have the culture and collaboration. I think the problem with the entire water. So I think it is suitable for those and you do that students that have more preference more for application and the teaching solution. Yeah, it's true. Because I think there is a situation in Indonesia, so maybe I don't have the right to answer the question. But only in my opinion, the marine ranching development is to keep the balance of the environment and the human being. The first thing we are doing some the agriculture. We always focus on the productivity and the production, but we maybe lot of the focus on the environment safety and the nature beauty. So marine ranching to balance the two things to keep a sustainable development. Development is the most important thing to develop the marine ranching. The water for the I think LT, 5G, it's also the water technology and AI. Some technology is very important for us. Now, no more, not only in but also in other world. Okay, now maybe they can do a deeper and convenient job, not be go to by themselves. They can just sit in the office and control the equipment to do the maybe easy jobs. Oh, how much for that? For square meter. 4 square meter. I think I may need to about 100 square meter. It's just like take the cucumber as an example. In our country in China, we also have about 20 kilograms. The cucumber is about 100 square meter. And it's about so it was in China 1 kilogram of cucumber is worth more than 100 yuan. It's about 200,000 rupiah in China. So you can calculate how yeah. Recently, they do operate include not close the open area. So we can use the gate to keep the fish not the gate. So in our we often do some numbers, slowly oysters and fish maybe familiar with the fish. I don't know how to speak English. That kind of that kind of salmon in our area. That's a salmon, kind of salmon. I don't know the name. Maybe we can communicate with each other, use because we can use. Thank you. Thank you so much.
Thank you very much, Professor Chin Gong-ling. Because we have limited time, now we move to the next speaker. It's honor my honor to introduce our next speaker, Dr. Muhammad Naufal. Dr. Muhammad Naufal holds the position of the Young Researcher at the Research Center for Marine Aquaculture. He earned his bachelor's degree in biology from Airlangga University in Indonesia, then completed his master in environmental engineering at the Institute of Technology Surabaya, Indonesia, and he received his PhD in environmental engineering from the prestigious National Cheng Kung University in Taiwan. Please join me in giving a very warm welcome to Dr. Muhammad Naufal, who will present his research on the development of HH disease detection technology in seaweed aquaculture. Time is yours.
Uh, thanks. Good afternoon, everyone. Thank you for the chance to deliver our research progress, especially in the pest application monitoring and detection kit development in the private aquaculture. My name is Muhammad Faisal. Next. Before we go further, I like to introduce about my research group because we are working under Marine Aquaculture Research Center in Green. And this is my research group, Marine Aquaculture Disease Control Research Group. Our vision is to provide the biotechnology solution for the healthier and more sustainable and adaptive marine cultivation to environmental changes. And Dr. Wahyu is our leader in our research group. We also have Dr. Ketut Mahardika, which has specialty in the mariculture disease and environment. We have Pak Ngurah, Muhammad Nafal is me, and Mr. Ahmad Muzaki, Dr. Lulu, Ibu Niwayan, and also Bu Indah Astuti. That's all of my research members. So let's go to the next slide. As we know that the seaweed is an important marine product, and we know that the first country that has the largest production of seaweed is China, and Indonesia now is number 2, but maybe in the next few years we can be the number 1. Maybe, yes, probably. And the total production for 2023, we can reach about 9.75 million tons, which is this amount is actually increased year by year. Next slide. And this slide also show us the 5 groups of seaweed that commonly commercially cultivated around the world. We have Undaria group, Hierophia group, Gracilaria group, Euchromatoid, and Saccharina group. But however, in Indonesia, we only focus into 2 different groups of seaweed, Euchromatoid and also Gracilaria. Next slide. And this map also show us how much is the global Euchromatoid production at 2023. As you can see in this map, the blue color shows the amount of the Euchromatoid production in Indonesia. In 2023, we can produce almost 8.2 million tons of Euchromatoid, and the second country with the largest production is China, with maybe only 1 something million ton at 2023. And for the next Gracilaria group in the next slide, you can see that the production of Gracilaria is higher in China compared to in Indonesia. Indonesia only produced 1.5 million ton of Gracilaria, which is maybe 10 times lower compared to the production of Gracilaria in China. The difference in the dominant seaweed production between Indonesia and China is caused by because the Capophycus is a tropical seaweed. Euchromatoid is good to grow in the tropical condition, whereas the Gracilaria is a kind of seaweed that can grow in a very wide range of environmental conditions. So the climatology and also the biological condition in China is good for Gracilaria to grow. Next slide. We know that the seaweed is an important product for fisheries and also for aquaculture in Indonesia. And seaweed also has many advantages for us. Seaweed can support the farming, and also seaweed can provide the carrageenan for the industries, and also seaweed can be agent for the ocean carbon sequestration. Why? Because of in the other side, seaweed can have the ability to absorb the CO2. So besides for the economical function, from the environmental side, seaweed is also good to capture the CO2. That's why we also put them as the carbon sequestration agent. Next slide. And this table or image show us the global Euchromatoid production at 2021. As you can see here, the production is increased from 1990 to 2015, but slightly decreased at 2020. And most of the decreasing of this seaweed product is actually caused by the disease, and people call it the ice disease outbreak. So what is ice? Ice disease is a common problem that occur in the seaweed cultivation zone, especially to the group of Caphophycus species. And this disease is actually caused by the combination of the environmental factors and also from the biotic factors. So once the environmental condition is fluctuate, for example, the sea between the rainy season or a dry season, the condition will change the water quality slightly high. So this condition will create the or will make the antibody of the seaweed decrease. So that condition will initiate the infection of the bacteria that cause the ice disease. But right now, most of the bacteria that involved in the ice disease or IID is Vibrio species and also the Pseudomonas species. Normally, for the species that has the IID, you can see from the morphology color, mostly they have the white color and they will have the soft tissue compared to the fresh one. And also, after such a long time, the tissue will disintegrate from the talu into a small part. So this condition is actually caused the yield production of seaweed become more decreased year by year. And this image show us the symptoms of ice disease. As you can see, I give the red line over there. That's how the white or whitish color shows the early symptoms of ice disease in the Caphophycus striatus. And besides white color, it also causes the raw color surface. So normally the raw part is not normal in the seaweed, but once these symptoms occur in the seaweed, so the surface will become more raw compared to the normal seaweed condition. However, after such a long term, and they can go into the advanced symptoms, as you can see in the right side of the image of the seaweed. The extensive whitening become more large, and it will cause the disintegration of the seaweed. Just like what we mentioned before, this condition will reduce the yield of the seaweed and also will reduce the carrageenan yield and also will affect the production in the marine. And we also did some studies by our team. We try to see how actually the seaweed will affect by contamination or infection by the bacteria which has potential to cause the ice disease. The top figure shows us the morphology of the Caphophycus species before we give the infection of the bacteria cause ice disease. And in the bottom two, you can see the whitish color occurred after we put the bacteria which has potential to cause ice disease as the 50% of the body or the colors become more white, and the left side is 60% bleaching occurs. So based on this our lab experiment, we can confirm that this bacteria is actually an agent to cause the ice disease, and this ice disease is actually can occur without the environmental stressor before. Next slide. So based on that previous information, we have some of challenge that actually we can detect in our daily life. So the current detection we can do is we can do the visual inspection. So we can see whether the whitish color occur or not. But this is very not because this is very subjective, because of maybe one people will say this is white because of the ice disease, or this white color is because of the environmental stressor. So the second current detection challenge is if we want to see whether the ISS disease is occurred or no, we should do some microbial isolation to see whether the microbe that has potential to cause the ISS disease is present or not. But this process is time consuming and it's also lab based, so it's not that efficient, especially for farmers who work mostly in the marine area. And the next detection we can do is by using the PCR or qPCR process. And this process is actually advanced. However, this process is much more costly because of the reagent and also the process of PCR and qPCR will take the spatial tool. So this is not that efficient, especially for the farmer. And also we can do the environmental monitoring, but once we do the environmental monitoring, for example, we can do the metagenomic analysis from our environmental DNA, we can detect many different kind of microbes. So the result is not that specific compared to the previous one. So until now, we don't have a rapid, affordable, and also the field deployable kit to check whether the environment is accurately contaminated by the ISS disease contaminated bacteria or not. So in our work, we have a small conceptual framework. So we believe that the environmental stressor is the main factors that cause the ISS disease. And this stress is actually can cause the microbiome shift, and also it can cause the initiation of the pathogenic bacteria, which cause the ISS symptoms into the seaweed. So our research group tried to develop the detection kit to have the tools as an early diagnosis tool, so we can have a good management process during the seaweed culture, so we can reduce the loss in the yield of the seaweed production. Right now, in our research group plan, we have 5 different phases, but the phase 1 right now, we are doing microbiome profiling. We want to see the abundance of the bacteria which commonly occur in the seaweed and also in the marine area where we grow the seaweed. And the phase 2 that we do right now is the biomarker identification and also to see the virulence genes in the seaweed aquaculture. Why this 2 process is important to create the kit design or primer design to detect the ISS disease, because we need to know what kind of bacteria or the microbes that highly expressed in the healthy seaweed or in the seaweed which has the ISS disease symptoms. Based on this information, we can know the core of microbes that potentially cause the ISS disease. So the next step is we can define the genes that involved in the ISS disease, so we can make the design for the PCR, even for the kit design or LAMP, and also doing some field validation. In our study, we have some sites that we use to do the microbial profiling to see the microbes that potentially cause the ISS disease. And in our research group, we took the seaweed culture area in the Lombok Timur, East Lombok, Nusa Tenggara Barat. So in our plan, in our phase of study, we took the water samples from the 3 different points, and also we took the seaweed sample to see whether there is an correlation between the microbes in the marine system and also from the seaweed system. Next. After doing some metagenomic analysis, as you can see in this table, we took the sample, the representative sample from seawater sample and also from the seaweed sample, which indicates by log 1 to 3 for the seawater sample, and the SWA-BC for the seaweed sample. As you can see here, the comparison of the diversity of the bacteria between the seaweed and the marine sample is significantly different. The amount of the diversity of the bacteria in the seaweed sample is slightly higher compared to the water sample, as you can see from the Chowan index, the ACE, and also from the Shannon and Simpson value here. The seaweed sample is more diverse compared to the seawater sample. And we try to find the core microbes among different location of the water sampling. So we can found that there is 191 of core microbes that occur among 3 different types of our sampling. But if you see into the right side of the figure, there is a clear differences between the microbes community that's taken from the seawater and also from the seaweed sample. The left side is the log 1, log 2, and log 3 shows the dominant bacteria in the seawater sample, and the Vibrio fortis is highly dominant in the seawater sample. However, once we take the sample from the seaweed sample, the highly dominant bacteria is from the Vibrio pneummonas something. So this image shows us the clear differences between the seaweed sample and also from the marine sample. So what I want to mention in this figure is based on the metagenomic data, it shows that the location 1, 2, 3 is actually affected by the presence of the Vibrio species, which we mentioned before as the agent to cause the ice disease. But we don't know whether how high is this abundance of this Vibrio in the colony per milli unit in that location. But this image shows us how vulnerable this location from the presence of the ice disease related bacteria. Next. And we try to do some genomic analysis, and we try to see the presence of the virulence related genes. So this gene is actually correlate to the presence of ice disease. For example, the biofilm formation and also the EPS synthesized genes, chemotaxis and the motility related genes, secretion system, and also the hemolysin toxin genes. This genes is actually common in the Vibrio bacteria related species, and it shows that this genes is actually occur in the system, whether in the seaweed samples and also in the marine samples. So this genes heat map shows how actually the location 1, 2, and 3 is vulnerable from this from the ice disease based on this gene heat map. So our study is not finished to the previous one, but the current study we do is we try to identify the core microbes within the health and also the ice disease seaweed. Based on this information, we can know the core microbes and create the detection level based on the microbial community and try to extract the genes that relate to the ice disease. And based on this, we can integrate this microbiome profile within the genes data, and we can design the PCR or qPCR primer or even the kit to early detection of ice disease. In the next slide, I will show you how we can do the PCR or qPCR kit, PCR and qPCR primer to detect the ice disease. Mostly, we will use the genomic analysis based on the abundance of the microbes in the location 1, 2, 3, and also within the healthy and also from the IID seaweed. And based on this information, we will do some genomic analysis and also doing some gene clustering and try to recover the genes that highly express that have the potential to cause the ice disease. So based on this information, we try to create this primer. So we hope this primer is useful. So we can try first in our lab, and also we can try we can do some trial in the field to see the efficiency and also the activity of the primer we want to create. So right now we hope that the in silico genomic analysis can give us a good result, so we can have the primer that can detect the ice disease, so we can have the early diagnosis of ice disease related bacteria, especially in the seaweed cultivated zone. Thank you. That's all presentation from me. Thank you so much.
Thank you for that excellent presentation, Dr. Muhammad Naufal. Now, do you have any question? Please raise your hand. Okay. Hello, my name is Nadia. I'm from Pijang, Indonesia. So this question probably out of the scope of this research. And let's say one of the seaweed culture did the detection with this kit. Let's say they detect the ice disease. Is there any discussion you guys have about what they have to do after they detect the ice disease? Thank you.
Thank you for the question. So once we do the monitoring process and we got the information that this area or the seaweed might have the potential of the ice disease, so once we can do it, we can, for example, in the seaweed, we can cut the area that already has the whitish color or has the potential syndrome of the ice disease. That's the first thing we can do. But for the marine water, what we can do is if we have the such amount of the area which has a lot of seaweed, we can start to do the early harvest process, because the spreading, once the advance of the ice disease is occur in the system, so the things we can do is doing the early harvesting process. Yes, that's we do to minimize the loss. But however, if the symptom is only the early syndrome, you can do only clean the rope you use to hide the seaweed, or you also can cut the area of the seaweed, part of the seaweed which has the symptom of the ice disease, something like that. But that's for the open system, because in the open system it's difficult to control the environmental condition. But if you have the closed system, like you have seaweed in the pond or something, it's easy for us, for example, to minimize the concentration of the nutrient. For example, if the nutrient loading is too high and you mention that the ISS is caused by the slightly increase of the nutrient, you can just normally add some more water to decrease the level of the stress. Or if your pond has high, suddenly low salt level, you can give maybe additional salt level. That's for the closed system. For the closed system, it's much more easy to control, but for the open system, you can do it maybe early harvesting or cut the area or part of the seaweed that potential hit by ice disease. It's not killed ice disease, but it can initiate the occurrence of ice disease, because once the fluctuation occur or suddenly salt change from 32 to from 28 to 32, this condition is good for Vibrio, especially for Vibrio species. They like the high salt concentration compared. For example, we just compare 28 to 32. Vibrio like 32 compared to 28. So this condition will enhance the growth of the Vibrio, and also the shock stress, the osmotic stress from the salt increasing or decrease of the salt will create the osmotic stress to the seaweed. So this condition will decrease if human will increase our antibody, it's also the same for the seaweed. So the bacteria will easy to interrupt the system of the seaweed. Yes. Thank you for the question.
Is there anyone here? Thank you.
Hello. Thank you, Mr. Novel, for your presentation. As you mentioned before in your presentation, that one of the factors that induce the eyesight disease is by the environment. So, do you have plan after develop the kit? Do you have a plan to develop a strain that resistant to these diseases? Because you mentioned that the genomic analysis that you are ongoing to do is maybe the best for the basic for the next step, which is the development of disease resistant seaweed. So do you have plan to develop this strain? Because it is hard to mitigate the environmental change because it's a global environmental change. So do you have plan to develop the seaweed strain that's resistant to eyesight diseases? Thank you.
Thank you, Dr. Faris, for the question. To create the high resistant seaweed to ISS disease is maybe not in our current object in our research group, but for the future, maybe we can do that. What we do right now is mainly focused in the detection of the ISS disease. Because if you want to do some of the genes in the seaweed to create the resistant seaweed is not in our expertise. Maybe we should have some collaboration with other research center in green, but for the future, I think we can do that. But right now, our focus is to create the detection kit first. Thank you.
Thank you. Now we move to question and a box. We have 3 questions. Okay, the first one from Novianto Gier.
The first question is, how far has the development of rapid, affordable, and field deployable diagnostic kit that can identify the pre-symptomatic stage? And okay, so right now, like what I mentioned before in our slide, we are in the phase 2 of our study. So we are in the step of distinguish between the microbes in the healthy and also in the ISS disease symptoms seaweed. So based on the profiling of the microbes, later we can create the sequence based on this microbe profiling data. So we can have the genes that highly occur in those bacteria. So we can start to create the specific primer for detection of those disease. But we are not look into the kit process in this in next year. Maybe for the kit is our next year project, because right now we want to create a highly efficiency of the detection, such as the primer for PCR and qPCR first. Maybe detection kit is our next step, like what I mentioned before. I hope that answer your question. And the second question is, what environmental factors that trigger the ISS disease more strongly? Temperature, salinity, or nutrients? I think from these 3 factors, temperature, salinity, and nutrients, temperature and salinity is more higher to create the ISS disease compared to the nutrients, because of for example, the salinity, it easily cause the osmotic stress to the seaweed, and this condition is actually irreversible, so it can easily decrease the survival of the seaweed. So the bacteria is much more easy to contaminate the seaweed. And the question from Nurul Wahyuni. Is there any new secondary metabolites that appear after the seaweed attack? We do some metabolite study before to see the concentration of some metabolites such as the carotenoid something. But in the first stage of the seaweed infection, the metabolite is highly expressed, but we don't know whether there are other metabolites is also expressed because we have not analyzed the metabolomics in a large scale, only in the specific metabolites, which only in the specific metabolites. But I don't know, but I think there is a possibility that some specific metabolites is also occur during the stress condition. Okay. Maybe one more question. Can ice disease be referred if the stressor is removed? I think the ice disease can be reversed if the stress level is in the early stage of the symptoms. For example, like when the whitish color starts to occur, we can directly cut that part and just move it from the environmental where we grow the seaweed. But if the contamination is in the advanced level, the thaly condition is become more easy to break down, something like that. So there is no chance to have the reversible or how to say that reverse condition of the seaweed depend on the ice disease contamination level. If it's advanced, so we cannot, but if it's just early stage, so it's okay to be, the seaweed can be reversed to the good condition. Thank you.
We have another question.
Oh. And next question from Yanuar Rizka. That's a good point. Early harvesting could be effective for immediate loss reduction, but perhaps integrating it with monitoring system or selective cultivation could help maintain the long-term sustainability. I think this is not a question, but this is the suggestion, and I agree with Mr. Yanuar. Thank you so much for your insight. And one more question. Quite a basic question. Does the couple could have an immune system to encounter the IID? Our research group doing some transcriptomic analysis, but right now the result shows that some of the genes is highly expressed during the stress condition, but some of the genes is decreased during this IID exposure. But I think that the Kapapekut has this immune system because some of the genes is highly upregulated during the stress. But I forgot the gene's name, but yes, I think they have the immune system to counter the ice disease. Thank you.
Thank you to our speaker for your expertise and for inspiring us. Let me to give a short conclusion from the presentation today. The first one from Professor Cheng Gang Lee has been given a comprehensive overview related to addressing the key challenge in modern marine lancing by establishing a sophisticated integrated technological system. The system is built on three core pillars: intelligent perception, intelligent control, and intelligent operation. Ultimately, this research demonstrates a transformative shift from traditional to a smart, efficient, and sustainable model for marine lancing. It paves the way for the future of ocean aquaculture. And from the second speaker, the successful development of the validation of this rapid detection kit will empower farmers with a timely and affordable tool, enabling early intervention and a better disease management. Ladies and gentlemen, we have arrived at the end of the webinar. I'd like to close the session by thanking for all presenters and for their participation in our session. Let's give a round of applause. Then to you, all of you participants, thank you. Your thoughtful question and active participation have made this webinar rich and meaningful. If you have additional questions, please feel free to approach the presenter. Enjoy the rest of the Adaptive Intelligence of Aquaculture Talk 2025. See you in the next hour webinar. Now we come to a moment of appreciation on behalf of the Research Center for Marine Aquaculture, Mr. Supono. We'd like to present a plaque to our speaker, Professor Cheng Gang Ling, in recognition of their outstanding presentation. Please stand and listen in front of Professor Cheng Gang Ling. And Mrs. Pujil Lestari, PhD.